Hello students, in today's class we'll discuss about redox reactions, then corrosion and rancidity. So in our previous lectures we have discussed about the different type of chemical reactions which are given in your class 10 textbook. We have discussed about combination, decomposition, displacement and double displacement. So in today's class we'll talk about redox and then we'll talk about corrosion and rancidity and their prevention. Now, when you say redox, the name redox itself says it is a combination of two different reactions. One is reduction and one is oxidation. So red stands for reduction, ox stands for oxidation. Now, when you talk about a reaction in which oxidation and reduction both takes place simultaneously, and then the reaction is called a redox reaction. So redox is oxidation and reduction that occurs simultaneously. Now, this redox can be explained in different ways, like the oxidation and reduction can be explained by using 5 different concepts. This redox can be explained by considering gain and loss of oxygen or any other electronegative element, gain and loss of hydrogen or any other electropositive element. In terms of gain and loss of electrons, redox can be explained. In terms of increase and decrease in oxidation number, redox can be explained. Or it can also be explained in terms of increase or decrease in electron density around the particular atom. But the last two concepts, that is oxidation number and electron density concepts, are beyond the scope of our studies in class 10. So here we'll talk about oxygen concept, hydrogen concept, and electronic concept only. So when you talk about in terms of oxygen, oxidation can be defined as addition of oxygen to a substance. So addition of oxygen to a substance is called oxidation. So if you see these particular reactions, in the first reaction, oxygen is added to magnesium to form magnesium oxide. So this is called oxidation of magnesium. In the second one, oxygen is added to copper to form copper oxide. So this is called oxidation of copper. So these reactions, in both the reactions, oxygen is added to the element. So this is called oxidation of that particular element. Similarly, reduction can be defined as removal of oxygen from a substance. So when oxygen is removed from a substance, this is called reduction. Like in the first case, from mercuric oxide, oxygen is removed. So this is reduction of mercuric oxide. Similarly, from zinc oxide, oxygen is removed to produce metallic zinc. So this is called reduction of zinc oxide. So in terms of oxygen, oxidation is addition of oxygen and reduction is removal of oxygen. Now, when you talk about hydrogen concept, this hydrogen concept is just opposite to the oxygen concept. Like we say, addition of oxygen is called oxidation. Here, removal of hydrogen will be called oxidation. So when hydrogen is removed, this is called oxidation. So if you see this reaction, in both the cases, from H2S, hydrogen is removed to give this elemental sulfur. So hydrogen is removed in both the cases. So these two reactions are called oxidation of H2S, where hydrogen is removed. So here reduction can be called addition of hydrogen to a substance. So when hydrogen is added to a substance, it's called reduction. Like in the first example, hydrogen is added to chlorine. So we say chlorine is reduced here. Hydrogen is added to sulfur, which is sulfur is reduced to give H2S in this particular reactions. And then this oxidation and reduction can again be defined in terms of gain or loss of electron. We know that during the formation of a cation, metal loses an electron. Like in this first example, when sodium forms a sodium plus ion, this is a cation, it loses one electron. So this loss of electron is called oxidation. So when an atom loses electron, this will be called oxidation. Similarly, in the second example, magnesium has lost 2 electrons to form magnesium 2 plus. So this can be called oxidation of magnesium. So in the first case, sodium is oxidized. In the second case, magnesium is oxidized. So loss of electron can be called oxidation. So reduction will be opposite. So this gain of electron by a species, by an atom, is called reduction. So in the first example, chlorine takes up an electron to form Cl minus and an ion. So this will be called reduction of chlorine. Similarly, in the second one, sulfur takes up 2 electrons to form sulfide ion. So since sulfur is taking electron, this will be called reduction of sulfur. So in terms of electron, oxidation can be defined as loss of electron and reduction is gain of electron. So we'll say it again. In terms of oxygen, gain of oxygen is oxidation, loss of oxygen is reduction. In terms of hydrogen is opposite. Loss of hydrogen is oxidation, gain of hydrogen is reduction. Similarly, in terms of electron also, loss of electron is oxidation and gain of electron is reduction. But this oxidation and reduction can never occur independently. So you have no reaction which is only oxidation, or you have no reaction which is only reduction. But sometimes we use the term independently. Individually, we say oxidation of a particular compound or reduction of a particular compound, depending on the compound that we are studying is getting oxidized or reduced. So if we talk about these examples, so in the first example, this one, copper oxide is getting converted to copper. So during the process, it has lost oxygen. So loss of oxidation is oxygen is reduction. That means copper oxide is reduced to metallic copper, and carbon becomes carbon monoxide. When carbon becomes carbon monoxide, it says taken oxygen plus oxygen, and addition of oxygen is called oxidation. That means in this reaction, copper oxide is reduced to copper and carbon is oxidized to carbon monoxide. So similarly, like whatever reaction is given, we can find out which element is oxidized and which element is reduced. Similarly, if we talk about this particular reaction, where H2S has been converted to sulfur and chlorine is converted to HCl. Now H2S to sulfur is loss of hydrogen. Like gain, loss of oxygen is called reduction, loss of hydrogen will be called oxidation. And chlorine has gain hydrogen, so gain of hydrogen is called reduction. That means in this reaction, H2S is oxidized and chlorine is reduced. If you see the next example, sodium reacts with chlorine to give NaCl. So you have to balance the reaction. To balance this, you can write a half here. And about balancing, we have discussed earlier in our earlier lessons. If you have some doubt, you can go to that and check the balancing. Now in this case, sodium is converted to Na+. So when sodium becomes Na+, it has to lose one electron. So when electron is lost by an atom, this is called oxidation. And chlorine becomes Cl-. So chlorine has taken an electron and gain of electron is called reduction. So during this reaction, sodium is oxidized and chlorine is reduced. So after this oxidation and reduction, we have to discuss about oxidizing and reducing agent. Now, what are these agents? Agents help in some work. Fine. So when you want to buy tickets, we'll go to agents who will purchase the ticket for you. So similarly in redox reaction also, we have some agents that helps. Now, what are these agents? These are called oxidizing agent or oxidant and reducing agent or reductant. So when you say oxidizing agent, these are the species that helps in reduction. So during an oxidation reaction or during a redox reaction, the species that helps in oxidation is called oxidizing agent. So they oxidize others and themselves get reduced. So the substance that helps other element, other atom, other molecule to oxidize, it itself will get reduced. That means the substance which is reduced, that will act as an oxidizing agent. Similarly, the substance which is oxidized will act as a reducing agent, because this oxidation reduction is giving and taking policy. If you give, I'll take. If I give, you will take. So one atom cannot give oxygen until and unless there is another atom to take. So the one that takes, that helps the other one to give, and one that gives helps the other one to take. So we can define reducing agent as the substance which helps in reduction, and the substance which gets oxidized act as reducing agent, and it said the substance which gets oxidized act as reducing agent in a redox reaction. Now, in exams, what is given in the question is they will give some reactions and they say identify the substance which is oxidized, the substance which is reduced, the oxidizing agent and the reducing agent in this particular reaction. So what I have to specify is the substance oxidized. So what is the substance oxidized? The substance reduced, oxidizing agent, and reducing agent. So there's 4 you have to identify. And you should know that all these oxidizing agent, reducing agent, substance oxidized, substance reduced will be seen in the reactant side. Now if we see the reaction properly, this H2S is oxidized to sulfur and oxygen is reduced to water. So H2S is oxidized to sulfur. So what is the substance oxidized? H2S. What is the substance reduced? Is oxygen. So substance reduced is the oxidizing agent and substance oxidized is the reducing agent. So this is how we can find out which is the substance oxidized, reduced, oxidizing agent and reducing agent. Let us see another example. In this case, carbon is oxidized to carbon dioxide and lead oxide is reduced to metallic lead. So here this lead oxide is the substance reduced. So reduced is lead oxide. Oxidized is carbon. So since lead oxide is reduced, it is the oxidizing agent. And carbon is oxidized, so it is a reducing agent. The substance which is oxidized is the reducing agent and the substance that is reduced is the oxidizing agent. So similarly, if you see this reaction, copper oxide is reduced to copper. So this copper oxide will be, it is a reduced substance. So it is the oxidizing agent. The substance that reduced is the oxidizing agent. Hydrogen is oxidized to water. So the substance oxidized is the reducing agent. Then some of the reactions that we have studied earlier, that is combination, decomposition, and displacement, are also redox. Not all combination are not redox. So if I talk about some examples, like if you say H2 plus O2 give H2, carbon monoxide plus oxygen gives carbon dioxide. So this type of combination reactions, this two are example of combination that we have studied earlier. So this type of combination reactions where some elements, at least one, is in the elemental form are redox reactions. So this is a redox reaction. But if we say combination like this, calcium oxide plus carbon dioxide gives calcium carbonate. So this type of combination where none of the reactant is in the elemental form are not a redox reaction. So all combinations are not redox. Similarly, if we talk about decompositions, where at least one of the product is the elemental form, will be a redox reaction. Suppose we'll take the reaction in the reverse way. We'll say H2O give H2 and O2. So here both the products are in elemental form. Similarly, if I say carbon dioxide breaks down to give carbon monoxide and oxygen. So in this case, one of the product is in elemental form. So these two reactions are redox. So when we talk about decomposition, if one of the product is present in the elemental form, then the decomposition reaction is redox. Similarly, if we go to displacement reactions, suppose we'll talk about zinc plus HCl. What we'll get here is ZnCl2 and H2. So in this case, this HCl is reduced to H2 and zinc is oxidized to ZnCl2. So this is oxidation and this is reduction. So the element which is more reactive gets oxidized. Another example, if you take iron plus copper sulfate. So what we'll get here is iron sulfate plus copper. So in this reaction, This iron is oxidized to iron sulfate. This is oxidation. And copper sulfate is reduced to copper. This is reduction. So displacement reactions are redox, where the more reactive element get oxidized and the less reactive element get reduced. But the double displacement reactions are not redox. So next we'll talk about corrosion. Now see, we know that a metal, if you take a metal, freshly cut metal, metals are lustrous. That means they have a shiny surface. But if you keep the metal in open for a long time, what will happen? So when a piece of metal is kept in open for a long time, it becomes dull. The surface of the metal will acquire some dullness because of some compound formed on the surface. So this formation of salts like oxides, carbonates, sulfides, etc. on the surface, due to which the metal become dull, it's called corrosion. So we can define corrosion as formation of some metal salt or oxides on the surface of a metal due to slow atmospheric oxidation is called corrosion. Now this corrosion is very harmful for us. We know this. If we talk about this picture, it shows a bridge where the iron get rusted. So once this iron get rusted, this bridge may collapse at any moment. Right? Similarly, some machine parts, if the machinery become get rusted, the metal inside get corroded, it get rusted, then it becomes difficult for the machine to run. So the first example or the best well-known example is corrosion of iron. This corrosion of iron is commonly called rusting. It's commonly called rusting, where iron reacts with oxygen in presence of water vapor to produce iron oxide and XH2O. This XH2O is called water of crystallization, but in case of rust, that water of crystallization is not fixed. About water of crystallization, you'll get in the acid and base, that particular chapter, next chapter. So then we'll talk about this. So you have understood what is this? Statue of Liberty. Now the Statue of Liberty, this brown was the old color. This is the old color and is a new color. So with time, it gets converted from this brown color, reddish brown color, to this green color. So why this transformation has taken place? This is because this Statue of Liberty is made up of copper. The surface is made up of copper, and the place where it is placed is humid because water is there every side. So because of this water, because of humid nature, the copper metal has reacted with a moist air and produced a copper carbonate, copper hydroxide compound, which is called basic copper carbonate on the surface, which is green in color. And is the reason why the Statue of Liberty has taken this particular color. And this color will now remain, it will not go. So copper develops a green color on the surface, which is again an example of corrosion. Similarly, silver becomes black in color. So silver articles, when it become old, it become black in color because the silver reacts with H2S present in the atmosphere to form a silver sulfide on the surface, which is black in color. So these are some examples of corrosion. We can talk about corrosion of aluminum, but in case of aluminum, corrosion is helpful. Like aluminum, when allowed to react with the atmospheric oxygen, this aluminum reacts with oxygen present in the atmosphere, it forms a layer of aluminum oxide on the surface. And this aluminum oxide layer is so tough, so hard, it prevents aluminum from further oxidation. So because of the formation of this layer of aluminum oxide, it can be used for making cooking utensils, fine, which will not react with the food items. Otherwise, aluminum is a reactive metal, so it should react with the food items, but it will not because of the formation of aluminum oxide. Then we'll have to talk about prevention of corrosion. See, this prevention of corrosion is necessary not to save money, but to prevent some accidents. Like in the earlier case, I said that bridge may collapse because of rusting. So that has to be prevented. Right? So how can this corrosion be prevented? Suppose we'll talk about a nut and a bolt. Now, if this is used somewhere in outdoor, it may get rusted after some days. So when it gets rusted, it may break, and which may lead to accident. So to prevent this, what is done? The nut and bolt is painted. So once paint is applied, what will happen? The paint will form a layer on the surface, which will not allow the metal to come in contact with the atmosphere. So the best way to prevent corrosion or prevent rusting is not to allow the metal to come in contact with the atmosphere. So how can that be done? It can be done by painting, as I explained already. So covering the surface with paint or some chemicals. If you cover the surface with some paint, then the metal will not come in contact with the atmosphere. As a result, it will not get rusted. By applying oil, by applying grease. Now, where we apply oil and grease? So when you talk about the machine parts that has to rotate, you cannot paint it. Like this ball bearing. If you paint this ball bearing, it will not rotate. So when it doesn't rotate, it is of no use. Fine. So we apply some grease in it. So grease, it looks like this sort of like Vaseline only, but this is the color is a bit different. It's a sticky petroleum product only. Then galvanization. So this galvanization is a process in which iron articles are taken and a coating of zinc is coated on the iron article. So a coating of zinc is given in the iron article, which prevent iron from rusting. Then this can be done by anodizing also. This anodizing is done for aluminum. These aluminum articles are taken as anode and sulfuric acid is electrolyzed. When sulfuric acid is electrolyzed at anode, it gives oxygen. The oxygen which is produced as anode will react with aluminum to form aluminum oxide layer. So this aluminum oxide layer is very hard and very smooth. It gives a fine surface, shiny finish to the metal, and the metal becomes like corrosion resistant. So if you see nowadays, many window panes, many sliding doors are made up of aluminum. If you see that aluminum, it's written somewhere, it is anodized by, and they write the name of the company who has done the anodizing. Then chrome plating, like chromium is coated by the process of electrolysis in a metal, and it gives a very shiny, fine finish to a metal, like this water tap. It is chrome plated. So chromium is one of the hardest metal. So when chrome plating is done, it looks better and this beauty remains for longer time. Nowadays, the vehicle also, in the front side and the back side, chrome grills are given. That chrome grills give a very, very fine, like beautiful look to the vehicle. Even when you talk about the Royal Enfield Bullet, in Royal Enfield bikes, the mudguard and the silencer pipe is made shiny by chrome plating. Then making alloys. We know that iron gets rusted easily, but an alloy of iron, that is stainless steel, will not get rusted. So by making alloys, which is a mixture of some metal or sometimes non-metal also, to improve upon some properties, like rusting, corrosion can also be prevented by making alloys. So these are some ways by which corrosion can be prevented. Now we'll talk about oxidation of food, where we'll talk about rancidity. Now see, when you keep butter in open for a long time, what will happen? If you keep butter in open for a few days, the taste and the smell changes. Why? Because the food that containing fat and oil, that contains fat and oil, when comes in contact with the atmospheric oxygen, they get oxidized. And because of oxidation, the taste and the smell of the food changes. It's destroyed. And this process is called rancidity. What will happen is the compound gets partially oxidized to carboxylic acids, aldehydes, and ketones that give this particular smell, this foul smell in the compound. Right? So this process is called rancidity. And this rancidity can be prevented by various ways, some of which we'll explain here. First one is by using antioxidants. These antioxidants are like bodyguards. They prevent the compound to get oxidized by themselves getting oxidized. If air sometimes comes, somehow oxygen comes, the antioxidants have more tendency to the oxygen. So they take the oxygen, get oxidized, and prevent the compound from oxidation. Fine. Some antioxidants which are commonly used in food industries are BHA, butylated hydroxyanyl salt, and butylated hydroxytoluene, BHT. So these are the compounds that makes butter to be kept for 1 hour. Otherwise, butter is a milk product, and milk product can be kept for only 2-3 days. We know that after that it gets destroyed. But if you see the butter packet, it's written best before 12 months. That means butter can be prevented, which is a milk product, but can be prevented for years by using, not years, for 1 year, by using these antioxidants. That if you buy these packets of chips, once you open it, you say, this is so less chips and it's filled with air. Actually, it's not air. They give inert atmosphere by filling this packet with nitrogen gas. So in these packets, they place nitrogen gas. So this nitrogen gas will give an inert atmosphere to the fats which are present there. As a result, the fats will not get rancid. Fine, they can be prevented. If you fill this with normal air contain oxygen 21%, so that oxygen will react to the food items and the taste and the smell will get destroyed. That means they get oxidized, they get rancid. So by packing the food in bags flushed with nitrogen, rancidity can be prevented. It can further be prevented by keeping the food at low temperature, by keeping the food in refrigerator. So when the food is kept in the refrigerator, the rancidity, the process of oxidation becomes slow. Actually, these oxidation processes are catalyzed by some enzymes, and the efficiency of the enzymes reduces at low temperature. Then it can be prevented by storing the food in airtight container. When you keep the food containing fat and oil in airtight container, the excess of oxygen is regulated. So as a result, rancidity can be prevented. Okay, thank you, students. We'll stop here for today. In our next class, we'll talk about the intakes and the back question of this particular chapter, and then we'll talk about some questions which are asked in previous year board exam.